Today's lesson for 5.3, we are going to continue solving systems, but today we're going to learn a third method. It is called solving by elimination. It may seem a bit confusing today, but elimination can sometimes be the easiest process for solving systems, especially when the equations are set up in standard form and you have ax plus by equals c for both of your equations. Again, you do not have to use elimination. You can always take both equations and isolate y, graph it, and find the intersection always. So today I'm going to do the examples with elimination. I will check my elimination work by graphing to prove that both ways work. And again, you choose the way that you prefer to ensure that you are going to get the correct answer. Okay, so elimination. Elimination means to eliminate something. So if we have two equations with two variables, we want to eliminate one of the equations and one of the variables. Okay, so if we take a look at these, negative 2x plus 4y equals 8, 6x minus 4y equals 0, you're going to notice that we have a positive 4y and a negative 4y. So to eliminate this, what we are going to do is combine the two equations into one. So we are going to take our x's, negative 2x plus 6x is going to be a 4x. And 4y minus 4y is 0. So you will notice that right from the beginning, my y values have been eliminated. Bring down your equals and combine your constants. 8 plus 0 is 8. Now we have one equation, 4x equals 8, with one variable. This, we can use our basic algebra skills, divide both sides by 4, and you learn that x equals 2. So as far as my solution over here, I know that the x value has to be 2. Alright, so now that I know x, let's take that and substitute it. And you get to pick whichever one you like. You can use the original top equation, or you can use the second equation. And I'm going to guess that most people want to use the 6x minus 4y because they want to stay away from the negative 2. But you don't have to at all. So we're going to take this 2 and substitute it into this bottom equation. So I'm going to have 6 times, well, instead of x, I'm going to replace it with a 2. And then I'm going to continue with minus 4y equals 0. So notice my equation has only a y as the missing variable, and that's the piece I'm still needing to find. So 6 times 2, 12. 12 minus 4y equals 0. Okay? Some of you with advanced algebra skills may choose to move the negative 4y. That will work. I'm going to go ahead and stick to our rules by moving the constant. We're going to subtract 12 on the left side of the equals and on the right side of the equals. Bring down negative 4y equals, and 0 minus 12 is negative 12. The very last step, we're going to divide both sides by negative 4. And you end up negative divided by negative is positive. 12 divided by 4 is 3. So our y value is 3. Okay, so right here, this is where the two lines should intersect if you choose to solve it graphically. So I'm going to go put that coordinate on here. 2, 3. There's the coordinate 2, 3. Okay, now I'm going to take an extra piece of paper here just for room, And I'm going to go ahead and I'm going to solve each of these for y. So my first equation, negative 2x plus 4y equals 8. All right, I am going to add the 2x over. I get 4y equals 2x plus 8. You'll notice that I'm always putting my mx value first and my b value last. That's to get into a habit of making sure my slope comes first. Divide everything by 4 and you get y equals 1/2 x plus 2. So let's go plot that on here on the graph. It's going to cross the y-axis at 2, rise 1, run 2. Look, it already is that common point that we are checking to see that the answer is correct. We're going to draw our linear function. Okay. All right, now we're going to look at the second equation. You'll see the second equation is 6x minus 4y equals 0. So again, let's isolate y. We will begin by subtracting 6x. Bring down, don't forget that negative in front of the 4y equals, well, we don't even need the 0. It's just going to be negative x. Divide by negative 4. Do not forget that negative. Negative divided by negative gives us the positive y. Negative divided by negative gives us a positive slope, and 6 over 4 reduces to 3 over 2. So make sure you simplify. Ooh, I'm off the page there. Okay, make sure you simplify 6 over 4 to 3 over 2. Okay, so remember the y-intercept is 0. We just marked that out. So it's going to cross the y-axis at 0. It's going to rise 3, run 2. So 1, 2, 3, 1, 2. Looky there. It goes through that same point. Ooh, I did that wrong. Rise 3, run 2. I could tell it was wrong because my points were not in a straight line. So that is wrong right there. Okay, so you'll notice whether you solve using elimination and you get the solution of 2, 3, or you isolate y and graph, you're still going to get the same solution here of 2, 3. So that is the third option. You can solve graphically. You can solve with substitution, or you can solve with elimination. All three ways work. So pick your most accurate way and use that most of the time. Obviously, you need to be very proficient at isolating y and graphing. So make sure you're very proficient at that before you move on to substitution or elimination. Okay. So sometimes you'll have to solve both equations for y, but it is still solved by graphing and finding the point of intersection. Okay, so this is referring to the graphing section. Yes, you are going to have to do some algebra. Whether you do elimination, substitution, or graphing, okay, you're going to have to do some algebra. So again, pick the way that you're most successful. I'm going to continue to do some elimination examples for this lesson today, but just remember, on your assignment and on any test that you take, whether it be a STAR, a MAP, an ACT, SAT, ASVAB, whatever it is, you can always solve by isolating y and graphing. Okay, so let's look at this second example. I have 16x minus 10y equals 10 and negative 8x plus 6y equals 6. So unlike this top one where the 4's were already set up to eliminate, I'm going to have to figure out how to eliminate one of the variables. Well, what I noticed right off the bat is I have 16x and minus 8x. So one is positive and one is negative. So if there was some way I could make this a negative 16, then I would be able to cancel out my x's. So how can I make that a negative 16? Well, don't we just have to double it? But if we double one term, we have to double everything. So we are going to multiply this whole equation by 2. And I get negative 16x minus 12y equals 12. I'm going to recopy the top equation over. 16x minus 10y equals 10. Now when I combine, my x's are going to eliminate each other. I'm left with negative 22y equals 22. Man, they sure have given me some nice numbers for this first lesson. So my last step right here is I'm going to divide everything by negative. Remember, it's a negative 22 we're dividing by. Negative 22. And when you divide that, you find out that the y value is negative 1. So when you go write your solution, be very careful because the first value you found is y. So your negative 1 has to go in the y spot. So be very careful about that. Okay, now I'm going to substitute negative 1 for y, and I get to choose any of these equations, whichever one that I feel like is the easiest. So I'm going to say that this one right here with the positive 16x is going to be the most basic for everybody. So here we go, 16x minus 10y, but I'm not putting y, I am replacing the y with a negative 1, and then finish the equation equals 10. All right, 16x, negative times negative is a positive, and 10 times 1 is 10, equals 10. Subtract 10 on both sides. Okay, this algebra, the numbers are pretty great. 10 minus 10 is 0. And the last step, divide by 16. And 0 divided by any number is always 0. So my x value, I'm going to put that first, is 0. Okay, I'm going to check this graphically. So I'm going to make sure that they intersect at 0, negative 1. That's where I think they should intersect. Okay, so let me get my blank paper to start isolating y. Okay. The first equation I had was 16x minus 10y equals 10. So I'm going to leave my y's, begin by subtracting 16x on both sides. Bring down negative 10y equals, all right, my 10 does not have an x, so these are not going to be combined into the same group. I'm going to keep it as negative 16x plus 10. It's actually easier when you don't have to combine like terms because you just write down exactly what you see. All right, now we're going to divide, and we're dividing the left and the right side by negative 10. So it has to be negative divided by negative. 10 divided by 10 gives us the 1y. It has to be a positive y. But if I divide the left side, I have to divide everything on the right side as well. So negative divided by negative is positive. 16 divided by 10. Anybody know what that is? Okay, they both reduced by 2, which would be 8 over 5. And then Positive divided by negative is negative. 10 divided by 10 is 1. Okay? Alright, so let's go ahead and grab another color here, and we're going to solve the second equation, which was negative 8x minus 6y equals 6. Add 8x to the right side of the equal sign. Don't forget to bring down the negative in front of 6y. Again, the 6 on the right side does not have an x, so we're going to keep these groups separate, 8x plus 6, and we're going to divide both sides by that negative 6. So divide everything by negative 6. And a positive divided by negative is negative. And these are both divisible by 2, so this is going to be 4/3 x. Positive divided by negative is negative. 6 divided by 6 is 1. So let's take these equations, and we're going to go plot. See if I can get both of these on here. I'm not sure if I can. See if I can fold this paper. All right, let's see. Can we see both of those here? Not really. So I'm going to have to go back and forth. Okay, my green one is y-intercept of negative 1, rise of 8, run of 5. Ooh, y-intercept of negative 1 is right on that. And then it was a rise of 8. Oh gosh, 1, 2, 3, 4, 5, 6, 7, 8 is going way off of here. So maybe let's do half of 8. We'll do half of 8 and half of 5. So 4 and 2.5. That's not great. 1, 2, 3, 4. But it's the best we can do manually. Now, if you go ahead and go to your calculator and you graph, you're going to be able to get some better points more than likely. Okay, and not have to plot decimal values. Okay, all right, the orange equation came out to be y equals negative 4/3 minus 1, so it's going to touch the y-axis at negative 1. Oh, look at that. They both touch the y-axis at negative 1. That tells you right there where the intersection is. But it goes down 4, right 3. Okay, so it touches that negative 1. It goes down 1, 2, 3, 4, right 1, 2, 3. Or I can put a dot up here in the top section by doing up 4 and left 3. Just reverse that direction on the slope. And we're going to draw this linear function. And I have just proved graphically, all right, I have proved by using elimination and by isolating y and graphing, my orange line's a little off, give me a little grace with my human error, but it crosses at 0, negative 1. Okay, good job there. All right, so here we have 2 more. Again, I'm going to keep using, for 2 more examples, we're going to keep using the elimination method so that you can see a few examples and then you can decide what you like and what you do not like. Okay, so I have negative x plus 7y, or sorry, minus 7y equals 14, and negative 4x minus 14y equals 28. Okay, neither one is automatically going to be eliminated. And neither one has a plus and a minus. So we're definitely going to have to change signs. So I'm just going to work with the x because they're here first. This is a negative 4x. So I am going to need, see if I can get this focused a little more. I'm going to need this to be a positive 4x. So first of all, I know I need to multiply by 4. But if I multiply by 4, it's going to be a negative 4x. So what do I do to make a negative turn positive? Negative times negative is positive. So let's distribute this. Negative 4 times negative x is a positive 4x. Negative 4 times negative 7 is a positive 28x. Oh, sorry, y. That's a y. And then I also am going to jump across this equal sign because I have to multiply everything by negative 4. And so let's see, 4 times 4 is 16, and then carry your 1, so you get negative 56. Okay, so now I don't need to change the bottom one. Negative 4x minus 14y equals 28. So let's combine here. I have set it up to eliminate my x's. 28y minus 14y is 14y. And negative 56 plus 28 is going to be a negative 28. Okay, now we're going to divide everything by 14. When you divide everything by 14, you get negative 2. Okay, so I know this value right here is negative 2. Okay, all right. Just double checking everything. So now that I know that y is negative 2, I can pick any equation that I want to substitute negative 2 and figure out what the y value is. Okay, so does anybody have a preference? If not, I'm just going to go with the top one. So we're going to use negative x minus 7 times negative 2 equals 14. Negative x, if I take a negative 7 times a negative 2, it's a plus 14 equals 14. Subtract 14 on both sides. We end up with negative x equals 0. And if you divide both sides by negative 1, you get x equals 0. Okay? Now you are more than welcome to go isolate y and solve graphically. Okay? So let's go ahead and get our paper and start doing that. Okay, we're going to begin with negative x minus 7y equals 14. Add x to both sides. We end up with negative 7y equals x plus 14. We're going to divide everything by a negative 7. And you got to remember there's a 1 in front of that x, so this becomes negative 1 over 7x minus 2. 14 divided by negative 7 is 2. Okay? The second equation we are going to isolate y is negative 4x minus 14y equals 28. Add your 4x to both sides. Bring down negative 14y equals 4x plus 28. Divide both sides by negative 14. You get y equals negative 2 over 7x minus 2. Look at how close these are. They're so very close. Okay? But they're not exactly the same. They're almost the same. So let's go ahead and let's work on plotting these. Alright, so the blue one is negative 2 on the y-axis. It goes down 1, right 7. So 1, 2, 3, 4, 5. Oh, it's way off of here. And the other way would be up and left. So that's going to pose a problem on plotting. We need to half this. So we would go down a half and right 3.5. 1, 2, 3 and a half. Okay, get your straight edge. Let's draw this linear function. Ooh. Okay. It's a little more difficult when you're estimating decimals like this, but you can clearly see because the equation has a y-intercept of -2, it is going to touch 0, -2. Same thing on the other equation. It also has a y-intercept of -2. So it is going to go down to right 7. So it's still going to start at -2. It's going to go down to right 7, which is way off. So that is going to pose another problem. And if we half it, it's down 1, right 3.5. So it's oh so close to the other one. So down 1, right 1, 2, 3.5. These are almost parallel, but they're not parallel. They're very, very close. They were only off by 1/7. They are intersecting at 0, -2. Okay, last example I'm going to use for elimination, and then I'm going to do the last 3 just graphically using the graphing with the calculator. Okay, so we have 3x minus 2y equals 2, and 5x minus 5y equals 10. So none are going to eliminate from the very beginning. So I've got to figure out how can I make the x's cancel out, how can I make the y's cancel out. So from the very beginning, one needs to be positive, one needs to be negative. That's the only way to actually get them to cancel out. Okay, your other thing is that one is having to find a common number here. So I'm going to begin, I think, I'm going to do the x's, and I'm going to turn them both to 15. So I'm going to multiply the top by 5. That is going to give me 15x minus 10y equals 10. And then I'm going to multiply the bottom one by not just a 3. A 3 would give me 15, but I need it to be a -15, right? So they cancel out. So this is going to be a -3. So when I distribute the -3, I get -15 plus 15y equals -30. Combine, my x's are going to eliminate. I end up with 5y equals -20. Divide both sides by 5, and my y value is -4. So in my solution, I know the y value over here is -4. Okay, I'm going to take this -4. I pick any equation. I just like to pick the top equation if nothing looks easier. And I'm going to do 3x minus 2, and instead of y, I'm going to substitute the -4 equals 2. -2 times -4 is a positive 8. Subtract your 8 on both sides. 3x equals -6. Divide both sides by 3, and we learn that your x value is -2. So I'm going to plot -2, -4. Here's where they should intersect. Okay, I did that pretty quickly, but we are on like our 5th example. So I'm now going to take the opportunity to solve each of these algebraically. So I'm going to begin with 3x minus 2y equals -10. Okay, I'm going to jump through this quickly. So subtract your 3x over. You get -3x minus 10. Divide everything by -2, and we get y equals positive 3x plus 5. All right, so I'm going to go graph that. It touches the y-axis at a positive 5. Ooh, and it has a slope of 3, 2. So I would rise 3, run 2, and put a point up here, but I don't have a coordinate plane. So instead of going up and right, I'm going to go down 3, left 2. Down 3, left 2. Uh-oh, something's wrong here. What's wrong? Is it going to go through the coordinate -2, -4? It's not. So let's go back and check and see what's going wrong with my equation. Let's see, did I start out right? Started with 3x minus 2y equals -10. Okay? When I subtracted over the 3x, I got minus 3x minus 10. And then I am dividing by -2, and a negative divided by negative is positive, and a negative divided by a negative is positive. I wonder if I have a sign mistake over here. -2, -4. I don't think that is wrong. So let me come back to that one in just a minute and see what's going on here. Okay? All right, so let's try the second equation. It is going to be 5x minus 5y equals 10. We're going to subtract our 5x over, and I get -5x plus 10. Divide everything by -5, and I get y equals, I have a -1x minus 2. So let's go plot this orange one. Goes through -2, and it has a slope of -1, +1, -1, +1. So this one doesn't seem to go through the point -2, -4 either. I feel like something's wrong with our equations here. Okay. All right, let me see. Oh, I see what's wrong. Do y'all see it? This is supposed to be 3x minus 2y equals 2. 3x minus 2y equals 2. So I kind of got confused here because I was using some other parts of the equation. That happens sometimes. So let's redo this one. 3x minus 2y equals 2 would give us -2y equals -3x plus 2. And now when we divide everything by -2, we get y equals +3 over x minus 1. All right, minus 1. That may be a little different for us. So let's see. Crosses at -1. It has a rise of 1, 2, 3, a run of 2. Okay, there we go. That is going to fix the purple equation. There you go. All right, now let's go back and let's see what's going on with our orange equation, because that didn't seem to go through either. Okay, let's just double check this. Let's see. Move over the x. It becomes negative. Divide by -5. That's correct. Negative divided by negative is +1. Oh, looky here. Negative divided by negative is going to be a +1. So, again, I kind of did these too quickly, and I had great algebra, but because I didn't pay attention to a few minor details, it was way off. However, I knew they were off because they should have been going through -2, 4. That's what I found with elimination. So let's regraph this. It still crosses the y-axis at -2, but my slope should be positive. All right, so crossing at -2, but the slope should be positive. Let's see what happens here now when I draw this linear function. There we go. Now that one actually does go through. Okay, it is -2, -4 where the intersection is located. Okay? All right, on the last three, they're asking you to actually graph these using your calculator. Okay? So, I have been solving plenty, and so I'm going to go ahead and give you what these should look like before you graph. So I'm going to put them in slope-intercept form. If I was you at this point, I would pause the video. Okay? Once you pause the video, isolate y, all 6 of these equations, and then come back and see if your equations were isolated correctly. Then graph them in your calculator and find the intersections. Okay? All right, so hopefully you've hit play again, and you are going to check your solutions. So our first equation, 3x minus 2y, that should isolate to be y equals 3 over 2x plus 5. And the second equation would isolate to be y equals negative 4x plus 16. Both of these will be graphed, and you will come up with one intersection, because if you notice, the slopes are different, so there will be one intersection. So you go identify those intersections. All right, the second problem, we are going to isolate y. So this first equation up here, we are going to get negative 1/4 x. And then we are going to have, okay, let me see here, 6 divided by 8 is going to be 3/4. And then this second equation, when we isolate y, we are going to end up with a negative 1/4 x, and then a positive 3/4. Ooh, wow, look at that. Everybody see that? These have the exact same slope and the exact same y-intercept. So these are the exact same line. That means this is infinite solutions. They are the exact same line. Okay? All right, so this last one, when we isolate y here, we are going to get a positive 2x plus 9 for the first one. And then the second one is going to be a negative 2/3 x plus 1. Notice their slopes are different, so they are going to intersect once. You go graph them and determine what that solution is. Okay? So we have now taught 3 different ways to solving systems. Graphically requires you to isolate y. Substitution, isolate one variable and substitute into the other equation. Or elimination is to eliminate one of the variables by combining the 2 equations. You pick the process that you feel like you will be most successful, and you can use that process on all of your assignments and assessments. That includes your STAR, your SAT, ACT, whichever assessment you are taking. So good luck with systems.